Hello, I am Dr.T.R.Heera, Assistant Professor, Department of Chemistry, Amet deemed to be University. I welcome you all to this video lecture on batteries. Advancements in the field of science, engineering and technology has inspired man to find new methods for uplifting his lifestyle. So, this has led to global rise in energy demand. Though different forms of energy are available, electrical energy in the form of portable is important. So, man has developed batteries. Batteries is a source of portable electrical energy. So, around 6 decades back, this was not domestic usage of batteries was very rare. It was used very rarely, mostly only for starters in the automobiles and radio sets and flash lamps, but nowadays we can easily find around 40 to 60 batteries in our houses hidden in the most of the consumer products in the form of clocks, watches and mobiles and laptops. So, batteries have become very common in domestic usage nowadays. So, what is this battery? Battery, the conversion of chemical energy into electrical energy is the main function of a battery. A single cell, a cell designates, cell means a single unit. A battery is a combination of two or more cells usually connected in series or parallel to supply the necessary current and voltage or both. Nowadays we use many different types of commercial cells. Commercial cells should have these basic requirements. They should meet these basic requirements, that is, it should be portable, it should be lightweight, and it should be economical, and it should have a stable voltage plateau, and it should be leak proof, it should be initial cost should be very less, and it should be capable of recharging, and it should be very durable, it should be useful for a longer period, and it should have a wide operational temperature range. So, these are some of the qualities, basic requirements of any commercial cell. Classification of cells. Cells are basically classified into two different types, primary cells and secondary cells. Primary cells are the cells which can be used only once and it cannot be recharged again and again. Once the active material is consumed, it cannot be again reused, whereas in the case of secondary cells, they can be recharged and used again and again. That is, the redox reaction that is taking place will be reversed during recharging. So, that is the difference between a primary cell and a secondary cell. Now, this primary cell can be will act only as a galvanic cell, that is, it can only convert chemical energy into electrical energy, whereas the secondary cell can be used as a storage cell, that is, while discharging it will act as a galvanic cell, converting the chemical energy into electrical energy, and at the same time while we are charging the battery, it will act as a electrolytic cell, that is, electrical energy will be converted into chemical energy. Now, we will see one type of storage cell, that is our secondary storage cell. Example is lead acid storage battery. So, in the picture you can see this lead storage battery. We have two electrodes. The electrodes are made of lead grids, and anode is lead plate and cathode is lead oxide, and our electrolyte is 20% concentration of sulfuric acid. So, a simplified form you can see in this figure. So, we can see the electrode reactions now. At the anode, lead is being converted into lead Pb2 plus and 2 electrons are coming out, because anode always oxidation reaction takes place. Oxidation means loss of electrons. So, Pb2 plus again reacts with SO4 2- and it forms lead sulphate. The overall anodic reaction will be Pb plus SO4 2- will forming PbSO4 and coming a release of 2 electrons, liberation of 2 electrons. So, what happens at the cathode? Cathode, I told you, it is lead oxide. Lead oxide will react with 4 H plus ion. This H plus ion is from sulfuric acid. PbO2 plus 4 H plus ion plus 2 electrons gives Pb2 plus 2 H2O. Next reaction is Pb2 plus. This Pb2 plus that is coming out will react with SO4 2- and forms PbSO4, lead sulphate. Again, overall cathodic reaction will be PbO2 plus 4 H plus SO4 2- will react with the 2 electrons and it will form PbSO4, that is lead sulphate and 2 molecules of water. The overall cell reaction will be lead and lead oxide combining with 2 molecules of sulfuric acid and forming 2 molecules of lead sulphate and 2 molecules of water. So, from this reaction we can find out that inside the cell sulfuric acid is being continuously consumed whereas water is being produced. So, what do we expect? The specific gravity or the density of sulfuric acid will be continuously reduced as the battery is being used. When the density of sulfuric acid in the battery falls below 1.20 gram per centimeter cube, the battery needs to be recharged. So, how do we recharge the cell? By passing electricity, the reaction will be reversed. The cell acts as an electrolytic cell depositing lead and lead dioxide on the electrodes. The net reaction during the charging and discharging is represented as follows, that is lead sulphide plus lead oxide plus 2 molecules of sulfuric acid giving lead sulphate and water. This is the discharging reaction, and while charging, water molecules and lead sulphate combine together to form sulfuric acid, lead oxide and lead. Applications of lead acid battery. This lead acid battery is mostly used in automobiles for starters, for starting the engine, and it is also used in telephone exchanges, it is used in emergency power supply systems, hospitals, very commonly used in laboratories, etc. And each electrode pair develops a potential of around 2 volts. So, in order to obtain a very higher potential, number of such electrodes are connected in series. So, lead storage batteries are extensively used. Now, we will see what are the disadvantages of this lead acid battery, that is the limitations of lead acid battery is that the potential decreases with decrease in the concentration of sulfuric acid. We saw from the cell reaction that continuously as we use the battery, the concentration, that is the density of sulfuric acid is being continuously decreased. So, with the decrease in the sulfuric acid concentration, the potential also will decrease. This is one of the major disadvantage of this type of battery. Then excessive discharge and quick charging shortens the life of the battery. Next, the cell potential and the effectiveness is reduced at low temperature. At low temperature, the effectivity or the efficiency of the battery is reduced drastically, and excessive charging may damage the electrode and may also lead to explosion. Excessive charging, when we charge to a larger extent, it may lead to explosion. Also, we know that lead is a heavy metal and it is a toxic metal. So, that is also one of the limitations of lead acid battery. The next type of battery that we will see today is nickel-cadmium cell. Nickel-cadmium cell is widely used in very commonly used in households and electronic devices. Most of the electronic devices make use of nickel-cadmium battery, and in the case of nickel-cadmium battery, the anode is cadmium and cathode is nickel coated on nickel oxide, and the electrolyte is KOH. In a button type cell, a cell cup acts as the cathode and a cell cover acts as the anode. The electrode consists of tablets wrapped in nickel wire gauze separated by a fine porous separator soaked in the electrolyte. The electrode reaction of nickel-cadmium cell: during discharge at the anode, cadmium reacts with OH minus of the electrolyte and it forms cadmium hydroxide and 2 electrons are liberated. At the anode, nickel oxide reacts with it takes up the 2 electrons and it forms nickel hydroxide. And the net cell reaction is cadmium and nickel oxide react together and form nickel hydroxide and cadmium hydroxide. Also we know that electrical energy is generated. During charging, the above reaction is reversed, and the open circuit voltage of this cell is between 1.4 volts and 1.2 volts, and it is the main advantage of this nickel cadmium cell is it is very compact, it is lightweight battery and has a very good cycle characteristics, capacity and long shelf life, that is it can be used for a longer period. And applications of nickel cadmium cell. Nickel cadmium cells are used in battery operated appliances such as pocket calculators, photo flash units, cordless garden tools and hearing aids, emergency lights and telemeters, etc. Next we will see about lithium batteries. Lithium batteries are very recently developed and it has got remarkable properties. Lithium metal is a very attractive option because it is a lithium metal is very attractive as an anode material because of its light weight. Lithium is a very lightweight metal and it has low electrode potential and high electrochemical equivalence and very high electrical conductivity. So, these are the reasons that makes lithium metal a very attractive option as an anodic material. For these reasons, use of lithium has predominated in the development of high performance and high energy density primary and secondary batteries. Lithium batteries are of two types. Again, it can be primary lithium batteries or secondary lithium batteries. Primary lithium batteries cannot be recharged, secondary lithium batteries can be recharged, and based on the cathode material that is used, lithium primary batteries can be classified into three different varieties that we will see in the next slide. Classification of lithium batteries. Lithium batteries are classified into primary and secondary batteries. Primary battery is not chargeable and secondary battery is chargeable. Based on the type of cathode material, lithium primary cells are classified as follows. Soluble cathode cells. In this type of cell, liquid or gaseous cathode materials such as sulfur dioxide or thionyl chloride can be used. These substances dissolve in the electrolyte and the electrolytes solvent, or either they will dissolve in the electrolyte or they are one of the solvent that is used for electrolyte dissolving the electrolyte. Okay. And second type is solid cathode cells. These type of cells use solid materials as a cathode substance. Example, vanadium pentoxide, copper oxide, copper sulfide, iron sulfide and manganese oxide. All these are examples of solid cathode cells, materials that are used in solid cathode cells. Whereas in all these batteries, lithium is used as the anode and cathode are different types. It may be a soluble cathode cell, it may be a solid cathode cell or maybe a solid electrolyte cell. This type of cell uses electrolytes in the solid form itself as the cathode. Examples are lead iodide and lead sulfide. So, these are solid electrolyte cathodes. The different types of electrolytes used are of the following: lithium salt solutions in organic solvents such as propylene carbonate, dioxylane, tetrahydrofuran, ethers, acetonitrile, etc. Solvents like thionyl chloride, sulfuryl chloride, which are also the electroactive species at the cathode, mixed with lithium salts to provide ionic conductivity. A lithium ion conducting solid electrolytes such as lithium iodide or lithium iodide plus aluminum oxide can also be used. An organic polymer which can conduct lithium ions, example polyethylene oxide, can also be used. A molten salt, example molten lithium chloride and plus potassium chloride can also be used as a electrolyte. Lithium batteries based on the combination of the above types of solvent electrolyte systems and positive electrodes have been produced and tested. So, this is a very recent development in the battery technology. Advantages of lithium batteries: high cell voltage up to above 4 volts depending on the cathode material. This is because of the very negative electrode potential of lithium ions. High energy density due to the low atomic mass of lithium. 1 Faraday is released by the dissolution of 7 grams of the metal. Operation over a wide range, temperature range from about 70 degrees Celsius to minus 40 degrees Celsius. So, flat discharge characteristic, constant voltage and resistance through most of the discharges of many lithium cells, and finally very superior shelf life. All these are the advantages of lithium cells. So, in today's lecture we have seen about different types of batteries, what are the applications of batteries. So, first we saw about lead acid battery. In lead acid battery the anode is lead and cathode is lead oxide, and then we saw about nickel-cadmium battery. Nickel-cadmium battery, anode is cadmium and cathode is nickel oxide, nickel coated on nickel oxide. And finally, we saw about lithium ion batteries. Lithium ion batteries are recent developments in the field of battery technology. I hope you got some idea about batteries. Thank you.